To find the derivative of logarithmic functions, specifically the natural logarithm of x, let's consider the function of y is equals to ln x. So consider um, the function y is equals to ln of x. Now, if you convert from logarithmic form to exponential form, this will be equal to, because we know this is same as y is equals to log 2 base e of x. So if you convert from logarithmic form to exponential form, this is the same as e to power y is equal to x. Now, or you can write this as x is equal to e to power y. What you're interested in here is the derivative, yeah, of this function. So what we have here is an inverse function. So what I'm going to do next is a way of differentiating inverse functions, but the process still remains the same. So basically, we can find the derivative of this. This function is written in terms of y. So x is a function of x is equals to e to power y, so it's just written in terms of y. The variable here is y. So we can differentiate it in terms of y with respect to y. So dx over dy will be equal to, because it's e to power y, the derivative of e to power something is just that. So this will be equal to e to power y. Um, and then one thing you have to remember, or you have to know, is that dy over dx is equal to 1 over dx over dy. Okay, that's a true statement. So basically what you're saying here is that dy over dx, yeah, will be equal to 1 over this. Yeah, it will be equal to 1 over this. And the derivative dx over dy, as we have here, the result for that is e to power y. So this will be equal to e to power y. But of course, you want our original function is in terms of x. So we want our derivative to be in terms of x. So, well, from our original statement that we had here, we know that e to power y is equal to x. So that implies that this is the same as 1 over x. So you can notice that if you have the original function, yeah, so we can conclude, uh, we can conclude that if y is equal to ln of x, yeah, then dy over dx will be equal to 1 over x. Okay, so basically, if you have a natural logarithm, yeah, y is equal to ln of x, then the derivative of that natural logarithm will just be 1 over x. Okay, so let's move on to the derivative of log to base a of x. Now, consider um, this function. Suppose we have y is equal to log to base a of x. We can change the base to e, and the reason behind that is already we know the derivative of the natural logarithm. So maybe by rewriting, changing the base to e, our result from the previous situation that we've just looked at can help us here. So change the base to e, so this will be equal to log to base e of x over log to base e of a, which will be equal to ln of x over log to base e of a, and this can be written as 1 over log to base e of a multiplied by ln x. Now I want you to think of this as a constant because it is a constant. Both a is a fixed number and e is a constant. So basically, this is a constant. It's like 2, 3, just a given number. The variable here is x. So basically, what we shall be differentiating is ln of x, but this remains the same. So what we shall end up with is dy over dx. So dy over dx will be equal to, and by the way, this constant here is basically 1 over ln a. Yeah. So this is same as 1 over ln a multiplied by ln x. So if we differentiate that, we shall end up with 1 over ln a, which just remains as it is, multiplied by the derivative of ln x is 1 over x. So our resulting derivative here will be 1 over x ln a if you just put this together. So what you're saying here is that if y is equal to log to base a of x, then dy over dx will be equal to 1 over x ln a. So if y is equal to log to base a of x, then dy over dx, yeah, it follows that dy over dx will be equal to 1 over x ln a. Okay, next let's look at derivative of a to power x. Now, to find the derivative of a to power x, we can do that by applying the exponential rule. So let's apply. Um, so here we have consider y is equal to a to power x, and what we want to do is to apply the exponential rule. I'll explain what that is. So the exponential rule, which should be in your formula booklets, we can be able to write this in terms of e to power something. So this can be written as y is equal to um, e to power ln a to power x. E to power ln a is the same as a, and this is what's called the exponential rule. Yeah. So this is the same as that. So which means this can be written as e to the power of x ln a. Yeah, x ln a. And the reason behind using the exponential rule is so that you can be able to use chain rule. Yeah, because here you have a function inside another function. And we know that if you have that kind of a situation, you can be able to apply chain rule to differentiate this function. So dy over dx will be equal to the derivative of the power, and the variable is just x, so that will be ln a, because that's just a constant. So ln a multiplied by e to power u, and u is just x ln a, so that will be e to power x ln a. Now we can be able now to rewrite this in terms of what we had originally. So this is the same as ln a multiplied by this is the same as that, which is the same as that, which is the same as that. So basically, this will be equal to a to power x. So we can rewrite this as a to power x ln a. Yeah, and we can generalize. So if y is equal to a to power x, then dy over dx will be equal to a to power x ln a. That's a true statement.